I'll be the first presenter today. My name is Pablo, and I'm a senior software engineer here at Katawiki within the platform team, and especially on the developer experience area of focus. And something about me, had a bit of a journey to arrive to this role. I started as a embedded software development in NXP semiconductors, and then I transitioned into more of a DevOps role within ING, and then I arrived finally here. And something about me, I come from Spain, so I talk a lot. People from Spain, they talk a lot, but okay, you came for a presentation, so you expected me to talk. And also we tend to talk fast, but I will try to slow down, but just be ready and get prepared. And actually, based on that, I wanted people to have some energy. So to start a bit energized. So if I can ask you to stand up, because we're going to have a bit of a Energizer session to start. Active. And also it will serve hopefully as an introduction of the topic of the presentation of today. So basically here, we're going to do something very simple. I will ask you a question. If the answer to that question is yes, you'll stand up, you'll keep standing up. Any other answer to that question, you will just sit down. Even if you don't understand me when I ask a question, you also sit down. Yeah, that's a very simple rules. And to make it a bit more fun, I will ask you to actually close your eyes. So you will not know who's standing up. Yeah, at the end of the game, if anyone is standing up, and I will ask you 3 or 4 questions. Yeah. All right, so if all of you now can close your eyes, please. And by the way, if you have to sit down, please open your eyes, because I've seen people actually with their eyes closed trying to sit down, touching the chair. I don't want any accidents. Yeah? All right, eyes closed, everyone. Yeah? Let's start with a very simple question, I think. Have you ever heard the sentence, but it works on my machine? Okay. No one sitting down. Good, you understood the game then, because I know everyone answer to that question was yes. All right, let's go for a bit more deep question. Have you ever worked in a company that used Kubernetes on the cloud? Okay, yeah, SREday presentation. Who's going to sit down? Next question. In that company that you worked with Kubernetes on the cloud, could you develop software without installing locally any sort of Kubernetes or Docker or container builder? Okay. We're losing some people now. All right, next one. In that same company, could you actually develop your code, or developers at the company could develop the code without installing anything on your laptop but a web browser? All right, I think the survivor can open your eyes, and I think he deserves a round of applause, because he he already experienced an amazing developer experience. To be honest, you don't need to be here, but the rest you can probably stay. Yeah. All right. So I hope everyone is energized and ready to hear me speaking. And so this is the title, From Local to Cloud-Based Development Environments. And the subtitle is very important, because it is our migration story. So this is not how you should do it. This is how we did it. And if you can get in good insights from it, then awesome. And if not, hopefully we have some good next 20 minutes. Okay, so this is the agenda for today. It'll be like a story, right? Why we did the change, our first attempt to go to cloud development environments, what are the challenges we face, specifically 3, how we overcame them, and what do we actually learn along the way. So it's very important for this kind of migration, the context of your company, right? This is very much unique to the culture, to engineering people, to how they work. So it's good to have some context at Katawiki, so you understand why we took certain decisions, why we moved to the clouds. And basically we have a microservice architecture on Kubernetes, fully running on Google Cloud Platform. And we come from a migration from a monolith architecture, which means that if you've been in these kind of processes, you have a lot of services that depend on each other. So to actually develop on them, you need to spin up more than just the service you're developing on. Then we have around 30 to 40 isolated development environments that we use daily and run simultaneously. And we support front-end, back-end, and QA flows. We are a team of 2, 3 DevX engineers that fluctuated during the project. And before we started this, we had 2 types of development environments. We were fully local, very limited, because as I said, you couldn't run most of your microservices that you needed. So you just run your microservice with some dependencies that you run containerized, like your database and Redis, some caching. And then we also had a local connection, a local development environment that connected to a Kubernetes remote cluster. And there you can simulate all your applications there in the cluster, and you can proxy them. And to give a bit of a better picture of the different, how we approach that path on the different development environments and structures, this is actually got from Kubernetes official documentation. So you have the pure offline development experience, where basically everything runs local on your laptop. And there are many tools to support this Minikube kind. We didn't have this at Katawiki basically because we couldn't run all our applications on the local laptops. Then you have what is called proxy. This is what we had at Katawiki. So basically you have applications running in your cluster, infrastructure as well running in your cluster, and your local development environment runs your application. And proxies communicates through the cluster through a network connection. And again, there are some tools like telepresence, MirrorLD. In Katawiki, we use telepresence for this. And this is where we wanted to move on to live setup. And as you can see there, the development environment is somewhere in the middle because it is running your application in the cloud, but you still have some things locally, like your code, for example, is locally, and then it syncs to the cloud. We'll talk a lot more about this during the presentation. And again, some tools that support this. And as you can imagine, the last development environment setup is purely online. You basically just have a browser that you can log in, and then from there on, you can code all in the cloud without having any piece of software running in your local laptop. And again, some tools that support these flows. And this is what we had at Katawiki, and this is where we moved to. So this is going to be this presentation, this story of the path transition from proxy to live development environments. So now, how I promised to start, why did we move to cloud-based development? First one that was very noticeable for the platform team. It was the local proxy setup we had. It was quite complex and had quite some maintenance because basically we had to maintain some operators in the cloud, in the cluster. There needs to be some configuration, some routing. We need to update the versions, etc., etc. So there was some maintenance there. While the cloud-based setup, once we set it up, it promised to be quite low in complexity and maintenance with very simple configurations and unified environments. Then an easy one that you go for cloud development is for high fidelity, right? You basically are very approaching how your production environment looks like. So if you develop there, you will have high fidelity. You'll have the same infra network runtime. While on the local proxy there was many times that when developers push their changes to the next phase of staging, things were broken because they didn't taste on the same environment. And also onboarding, once you have this setup, the only thing a developer needs is the permissions, and then they're just a simple tool, and then they're ready to go to start developing on the microservice. While a local proxy, you will need to set up your local stat, etc., the tooling, and so on. And to be honest, there are many more reasons. I'm not going to go through all of them, but basically, in the end, it all translates to this, right? We are searching for better developer experience, and that's what matters. So how do we try this? What was our first attempt? So we use a tool that I already mentioned there. It was very little, but we use a tool called Till. And basically how they advertise the tool and how it does work. It's a toolkit for fixing the pains of microservice development. It offers you a UI, unified UI, where you have all your dependencies, all the services, and also the login. And it's an open source tool, though during the process that we were using it, it actually was acquired by Docker. So maybe some of you get discouraged by that, I don't know. But the promise was that it's really fast feedback loops, and there's very little setup, but very powerful configuration. And let me explain you how we set it up and what was our initial implementation. So basically, we had in the laptop of the developers, of course, we need to set up some permissions for the cluster to develop. And then you have your code, you have the Till setup, where basically you install the tool and some configuration. And initially, we also had a container builder there on the laptop. And once you just do one command, tilt up, it will deploy your application. In our case, in Katawiki, we had a Helm to deploy, and every developer has its own namespace in Kubernetes. And then it will also set up all your infra, so you're ready to go. And in GCP, you will have the connection. And here is where the magic of Tilt happens. Once everything is set up and running, your infra and your application, then any change you do on your laptop, in the matter of seconds, will be synced to your container without any disruption, and you will see your changes applied. So that's where the magic comes, and that's why we choose also Tilt, because of how easy it was to set up and how fast was the feedback loop. So basically, we stopped simulating the cloud and started developing in it, and it was awesome. Said no developer ever. Why? Because there are challenges when you move these things, right? And maybe this is good for a sales speech for someone selling the tool, but as I promised, this is a real story. So we're going to show you the real challenges that we face, especially 3 of them. The first one, I just told you that it was a very fast feedback loop, right? But I also said something, once it's up and running. To get there, to be up and running, you need to do things that you do not need to do when you have a local development setup. Because in the setup we had before, we didn't need to build images. They just start the processes, you're there, Rails start, and then you don't need to build images. So that you need to take into account now to set a process. There are also network transfers. You need to transfer that image to a registry. That image needs to be pulled by Kubernetes. It needs to be deployed by the Google Kubernetes engine. You also need to spin up dependencies and infrastructure. That also needs to be done before. But anyway, this is time that adds up. And it's true that when you make code, it is very fast. But if that code that you make triggers a container restart, that means Kubernetes needs to, again, schedule another container, another pod, deploy it, and so on. So you will feel that pain, when you make those kind of changes. So it's important that your developers don't need to make that kind of changes quite often. And when you move to the cloud, you're not anymore in the comfort of your local laptop. You know where you're running. Here, you're sharing some resources with other workloads. So sometimes timings are not deterministic, right? In the morning, you're very early bird. No one is developing. Your things work very fast. If you do the same thing at 2 o'clock, maybe things are not so fast. So we had to challenge this. We had this challenge. Then a second one, the customization complexity. So initially, as I said, Tel was very flexible, and actually it's code. That's how it's infrastructure as a code, actually. And we allow the developers, we expose the log to the developers because we thought, okay, you are developers, you like coding, you understand code, so you will understand this. And if you want, we'll set it up for you initially, but if you want, you can customize, you can modify it. It's up to you. But of course, this will require time and effort to understand. And the Tilt is a bit of special because it looks like Python. It may trick you at first, but it is not Python. And then there are many libraries and many Pythonic ways that do not work. And actually here in Katawiki, they're not the most familiar for some of this because we run Ruby on Rails on most of our microservices. So it was a bit new. Nothing too different from Ruby, but it's still a bit of a gap. And this is the third challenge, probably the hardest challenge, which was the developer sentiment. So when you move from a local development environment that you control, that you own, that you're familiar, to a Kubernetes base, that felt disruptive because it was disruptive. So many developers ask, where are my logs now? Why can't I just change my library version as I did before? Why does this take longer than before? And my favorite question, what's wrong with the setup that worked yesterday? And I'm not blaming or pointing fingers to developers, by no means, because actually these are the things we should care about, because these are the things that if we were developers, we'll be asking ourselves. So when you do this kind of change, you will have a loss of control, but which will feel like a downgrade to many developers. And also we had early friction because of the technical issues that we said before, that led to some frustration and some pushback from the development community, which is completely understandable. So finally, what do we do to challenge this, right? To overcome these issues? The first one, of course, you need to tackle the technical challenges. You need to reduce the feedback loop. This is very important when you're in cloud-based development. So the first thing to do is to optimize the image builds. So we modify the Docker file images. We use multi-stage Docker files because that way you can slim down your images a lot. So then the network transfers, the time to build will be quite fast. We enable caching as much as we could. We leverage pre-built images. We build containers in the cloud. We also tune the cluster resources to ensure that that pods have the enough resources they need, so developers don't feel that slowness when the cluster was under a heavy load. We also use container process managers, and we also try to reduce certain dependencies needed for the app. And let me show you how this looked a bit on the diagram before. So this was the initial implementation. And one of the first measurements we did to reduce that feedback loop was to move containers to the cloud. And this was very important for many reasons. First of all, because we are on that path to move things to the cloud. And that was one of the things that was still failing for developers. Like my caching, Docker caching is filling up. My image is not running because I'm not using the right flags on my laptop. And it's not the same OS that is running on the VMs. So all those problems went away when we started building containers in the cloud. And then, we could leverage the more powerful machines there. So things were faster. Then we also use pre-built images. This is a bit of a tricky one because you want to test your code. So if you use a pre-built image, how do you actually test your code? That's because we did some kind of clever synchronization, and we basically searched for the commit the developer had at that moment in his code. And then if there was an image that we built already with that commit, then that will be pulled, and then we can start from there. So your code is synced, and then Tilt will take care of the rest. And if not, we basically the developer switches the branch to master, and there is always a master pre-built image. And then from then on, then we can do the sync. And that is actually much faster than basically doing the build yourself. But of course, you need to take care of the synchronizations, and there is some tricky business there. But that, as you can imagine, reduces time to 0 to build images. Yeah. And then finally, the container process manager. This was also very important because, as I said, when you make a code change, it's very fast to go in a container and you see the code change. But the problem is that when that change triggers a restart of your application process, for example, I don't know, your next year server, if you're developing a front end, that will cause your container to go down. So then what we needed to do is to have a container process manager. In the case, for example, of front end, it was a Node one. We use a tool that basically controls that process and it makes sure that the container never dies. Yeah. So then you will never feel that slowness zone again as well. All right. Second challenge and how we tackle it, we reduce the customization complexity. Yeah, this is if I can sum it up in one very easy word: abstractions. We abstract the complexity to developers, right? So we went from infrastructure as a code to developers to a YAML file. Yeah. And we also added some quality of life features, some schema validation, so basically the setups didn't go all over the place. We validate you follow a structure, and it's very smooth to transition from one service to another. And basically now how the picture looks, we had a central repo maintained by us where we hide all the complexity. It's still open to developers, so they could contribute, the ones interested. But they didn't need to bother about that if they didn't want to. And this is just an illustration of how it looked. This is how it was before. As I said, we exposed the logic. This is how a tilt file, the configuration tilt file looks like with all the functions, your variables. It's just code. But then we moved to this, which, as you can imagine, for people that don't want to care about your infrastructure, this is much simpler. And the final one, the developer sentiment. The first one is easy to solve actually the technical problems that they care about. Make your feedback loop very fast. And before you start promoting the tool to the whole company, you can just reduce the friction that will have and improve your tooling. Second one, very important, solve the data. When someone comes to you and tells you, my development environment is very slow, if you don't have any data, you don't know if, how slow is that, right? Is it slow for him? Is it actually very slow? So you need the data. So you need to show the data and you say, okay, you're right. This was very slow. And this was because of this reason, right? Basically you need to let the outcomes tell the story, not just the opinions. And as a developer experience and as a SRE platform team in KataWiki, you need to be visible. You need to be patient because, people get frustrated sometimes. You also need to advocate a lot if you believe in this and your vision. And I repeat and repeat. Okay, so what are the things we learn along the way? We learn a lot of things, but I just highlighted 3 of them, which I think it would be nice to share with you. I already mentioned it a lot, but feedback loop speed is everything, especially when you move to the cloud. You will do an overhead of things that you do not have locally, and also you will be doing them, not the developer. It's different when the developer spins up his microservice and starts a new process that he likes because it's a new benchmark that he likes to check. But here you will be taking decisions from them, so it's important that is fast. If that is not fast, your migration to the cloud development will fail. This one I think we all know, but it was a good reminder during this process. Developers do not care about your infrastructure. And to be honest, they shouldn't. And the ones that should they should be in your SRE teams. This, it was the example that I show in the configuration of the tooling. You basically thought in the beginning that, okay, they are developers, this is code, they will like it, they will maybe even help us, they will change some things. But when you are a developer, you want to develop your code, not the platform team's code. So it is important to take this into account. And once we abstracted that and we just simplify them and let them focus on their code, that actually worked much better. And the final one, also, this could apply to almost everything we do because we are all people until AI takes over. So it's not just technical, it is emotional. At least good engineers I know, most of them are very proud of their craft. And when you do this kind of migrations, you are going to the core of their work. You're telling them a bit how to do things. They still decide what they do, but you are going a bit into that space. So it is normal that these things will become emotional. So even if you have the best technical implementation, which is hard, it can be someone that, because of the ways they used to do things, they still feel this is slower. They do not believe in it. So you also need to understand that, because it could be that indeed they are faster with some hacking ways or some special tools that it's only local. So you need to be flexible. You need to allow for this transition period. And you always need to remember that this is a bit of an emotional topic for many developers. So that was the journey we went through. And yeah, thank you a lot for listening.